Hello dear students, welcome to the chapter motion. Today we will discuss about the velocity time graph. In the last class we have already discussed about the distance time graph. We have already discussed about the distance time graph. And here in the distance time graph we have plotted the graph between the distance and time. Taking the distance in y-axis and taking the time in x-axis, we have plotted the distance time graph for three different situations. The situations are when the object is at rest or the body is at rest, then the distance time graph is a straight line parallel to x-axis. And the second situation is when the body is moving with uniform speed, then the distance time graph is a straight line. And when the body is moving with a non-uniform speed, then the distance time graph is not a straight line. So we have already discussed about the distance time graph. Today we will discuss about the velocity time graph. We have to discuss about the velocity time graph. You already know about what is velocity. Today we will discuss about the velocity time graph. From the heading, it is very clear that the graph to be plotted in between the time and velocity. So, what is velocity? Velocity is the rate of change of displacement. That is, when the body is moving from one place to other, it must have displacement and it must have covered certain distance in certain time. Therefore, the moving body having the velocity in certain time. So, in the velocity time graph, we have to plot the graph in between the velocity and time. Here also three different situations are there. What is the situation? Three different situations are here. Situation 1, the velocity time graph or the VT graph for uniform velocity. VT graph for uniform velocity, that is when the body is moving in uniform velocity, we have to see about the VT graph or velocity time graph. Then VT graph for uniformly accelerated motion. VT graph for uniformly accelerated motion. That means the velocity time graph when the body is moving with a velocity which is increasing uniformly, so we can call it uniformly accelerated motion. And the situation 3 or case 3, that is the VT graph. That is the VT graph for non-uniformly accelerated motion. VT graph for non-uniformly accelerated motion. That means here the velocity time graph for a moving body which is moving with a non-uniform velocity or which is moving with a velocity which is increasing or decreasing non-uniformly, and it is called accelerated motion and non-uniformly accelerated motion. So one by one we will discuss all these three situations. First, VT graph for uniform velocity. The velocity time graph for uniform velocity. Velocity time graph for uniform velocity. Listen, what is uniform velocity? When the body is moving with a constant velocity, that is called the uniform velocity. For example, a moving body is moving with a velocity of 40 km per hour. 40 km per hour, that is the velocity, and the velocity does not change. That means the body is moving with a constant velocity, that is the 40 km per hour. And here we have to plot the graph by taking the velocity and time. Here also the graph to be plotted by taking two axes. This is the x-axis, this is the origin, and this is the y-axis. And always we are taking the time in x-axis. We are taking the time in x-axis, and we are taking the velocity in y-axis. We can tell the velocity we are taking in y-axis. Okay, so time and velocity. We have to here the time is taken in hour, and here the velocity is taken in kilometer per hour or kilometer hour inverse. Okay, so 1, 2, 3, 4, 5, 6. Here 10, 20, 30, 40, 50. We have to write the unit. Here we have to write the unit. In x-axis, 1 unit is equal to 1 hour. In y-axis, 1 unit is equal to, in y-axis 1 unit is equal to 10 km per hour or 10 km hour inverse. In x-axis we have taken the time in hour, that is 1 unit 1 hour, and in y-axis the unit is taken 10 km, 1 unit 10 kilometers. Okay, so when the body is moving with a constant velocity or uniform velocity, that is 40 km per hour. So when it is 1 hour, the velocity is 40 km. When it is 2 hours, the velocity is same 40 km per hour. It is 3 hours, the velocity is same 40 km per hour. So here the graph will like this. The graph is like this, as it is a uniform velocity. If we join, a straight line will come which is parallel to x-axis. Here this graph, it is a straight line which is parallel to x-axis. As the velocity is constant, so it is parallel to x-axis. So it is a case of uniform velocity. When the body is moving with uniform velocity 40 km per hour, then the graph is like this. The graph is parallel to x-axis. Okay, we have to take any 2 points on this graph. Let us see what we can derive from this graph. Let's see, suppose here is a point A, here is a point B. Let us take 2 points on this graph A and B. Now draw the lines parallel to y-axis from the point A to the x-axis. Draw another line parallel to y-axis from B to x-axis, like this. Okay, suppose here this is the time, here time t1, and here the time is t2. So what we have done, we have first drawn one line which is parallel to y-axis from point A to the x-axis. Again we have drawn another line parallel to y-axis from B to the x-axis, and here this line meets x-axis at t1, and this line intersects or meets the x-axis at t2. Okay. Now let us see. Here we can give the name like C and D. This point is C and this point is D. Let us give the name here. I am giving the name in black letter C and D. This is A, B. This is Here you can give C. Here you can give the D. A, B, C, D. And it is a rectangle. It is coming A, B, C, D. Okay. In y-axis, this is the velocity. In x-axis, this is the time. And already we know the relationship between the velocity and time. The velocity is equal to displacement by time. Velocity is equal to displacement by time. Velocity is equal to displacement by time. So we can write displacement is equal to velocity into time. From this graph, by multiplying velocity with time, we can calculate the displacement of the object. By multiplying velocity and time, here the velocity is given, here the time is given, we can calculate the velocity. Let us see how we can calculate the velocity by just multiplying displacement by multiplying velocity and time. See, this one A, B, C, D is a rectangle. A, B, C, D is a rectangle. In this rectangle, the height DA is 40. The height CB also 40. And what about the CD? Here CT2, here DT1. So OC minus OD is equal to CD. So we can write CD is equal to D2 minus T1. Okay. So displacement, we can here the displacement is AB. For example, if it is displaced from A to B, then the displacement is equal to velocity into time. Here the velocity is 40 km per hour into time. We can write the time, that is T2 minus T1. 40 the velocity and the time is T2 minus T1. Okay. This 40, it is the AD. In place of 40 we can write AD. In place of T2 minus T1 we can write DC. AD 40 and DC T2 minus T1. So we can write in place of AD into DC, that is the area of triangle, area of rectangle ABCD. Area of rectangle ABCD. So the displacement is the area of rectangle ABCD. So in this case, when the body is moving with uniform velocity, the displacement can be calculated by calculating the area of the rectangle ABCD, or the area obtained by the graph with the time axis or with the x-axis. This area represents the displacement of that vehicle. Okay.